All right. Hello, Senior Math. Welcome back. Let's see. So last Friday, we were talking about standard deviation and variability. So what we had talked about last Friday was that when trying to measure the variability of a range of data points, it can be helpful for us to see the spread of that data. One of those ways that we could look at variability was the range, but the range only told us the distance from the highest to lowest number, and that wasn't a very good way. So we talked about another way of measuring variability. A little bit more effective way was measuring the average distance from each of our points to that median. And this was known as deviations. And that average was our standard deviation. So we looked at what was the distance between each of our data points to the mean of our data, and that helped us give an idea of how widely spread or how close those points were together based off that standard deviation, that average of deviations. Now, the way we calculated this on Friday was this fun looking formula we had here. And once again, I sort of broke this down into a few steps for us. So step number one, we had to subtract the mean from each of our points. So we found the mean, and then we took each of those points and we subtracted it from mean. So if your mean was 5, you would take your first point, subtract 5. Take your second point, subtract 5. Take your next point, subtract 5. Once we got all those values, we squared each of those results. So we squared each of those results. So if your first point minus 5 was 2, we'd square and we'd get 4. Once you took all your squares, we added them together to get a value. From there, we divided that added total by the number of numbers that we had. So if we had 5 data points, we divide that total by 5. If we had 7 data points, we divided by 7. And then lastly, we took the square root of all of that values, or of that division right there, and that was our standard deviation. Now, I mentioned on Friday that there was a second method of how to learn this. So that's what we're going to look at today, is what is the second method. But once again, I just want to show you a quick example. This is the example we did at the very end of Friday. So we have our points 1, 2, 3, 4, and 5, or 1, 2, 3, and 5. So step number one, once again, we took each of those values and we added them together and then we divided by 5. So that was our mean. So our mean was 22.1. Once we got our mean, we took each of our points and then we subtracted that mean from it. So 1 minus 2.4 gave us negative 1.4. 1 minus 2.4 gave us negative 1.4. 2 minus 2.4 gave us negative 0.4. So we did that for each of our data points. We found what was the value minus the mean for each of our data points. Then step number 3 was we squared each of those values. So negative 1.4 squared was 1.96. Negative 0.4 was 1.6. And we squared each of those values. And then step number 4 after that was we added all of those data points together. So 1.96 plus 1.96 plus 0.196 plus 3.6. We added all those together and we got 11.2. Once we got 11.2, all we had to do was 2 more steps after that. We divided by the number of terms we had. So we had 5 values given to us. So we divided 11.2 by 5 and we got 2.24. And then lastly, we took the square root of 2.24, and that was our standard deviation of 1.49. Now, this was our strategy that we had learned on Friday. And this is an effective method. And if you're comfortable with this, that's okay. You can stick with it this whole time. If you're not, we're going to learn about a second method that you might prefer. Students typically go back and forth whether they prefer the first method I teach them or whether they prefer the second method. So I'll show you both, and you can decide which one you like. So the second method has a little bit, I think the formula is a little bit more intimidating. So this is your formula right here. S squared equals the standard, or equals the summation of all your terms squared minus the summation of all your terms squared divided by n divided by n. So let's talk about what each of these things represent. So first thing, summation of all your terms. So this value right here, where it's that Greek letter sigma that looks like a big E with an X, this just means all your terms added together. So all your terms added together. So in this case, with all of our terms are 1, 1, 2, 3, 5, we would just add all these together, and that would be this number that goes inside the parentheses. Now, this is actually, so the number of all your terms added together squared with the parentheses around it and the one that without parentheses around it is technically different, because this is all of your squared terms added together. So So we're actually finding two values. So we're going to square all these numbers and add them together, and then we're just going to plainly add all these numbers together and then square. There is a difference between these two. Typically, you can just use your calculator and just type in the formula, and the calculator is going to worry about the rest. But we're going to walk through this. So the first step to do with a problem like this is we're going to make a table. So we're going to make a table. And in this table, we're going to have our normal terms on one side, and we're going to have our terms squared on the other side. So my normal terms are 1, 1, 2, 3, and 5. These are my normal terms. Now I'm going to square each of these numbers. So 1 squared is just 1 times 1, which is 1. 1 squared is the same thing. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. And then 5 squared is 25. 5 times 5. So we have each of these values. My pen will write. There we go. All right. Once we get each of these terms, now once again, these letters up here represented the summation, the adding of all of those terms together. So I'm going to sum each of these values. So I'm going to look at my left-hand column of all my x's, and I'm going to add each of these together. So 1 plus 2 plus 3 plus 5, and the summation of all of those terms should come out to be 12. And I'm going to do the exact same thing with my right side. I'm going to add 1 plus 4 plus 9 plus 25. I'm going to sum up all my squared terms. The summation of all my squared terms is going to give me 40. So now I have two numbers. I have 12 and 40. And these are my two numbers I'm going to use in my formula. So once again, it's s squared, which represents our variance, is the summation of all of our squared terms minus the summation of all our terms squared divided by the number of numbers that we have divided by the number of numbers we have. N is always going to be your number of terms that we have. In this case, it's 5. So the summation of all my squared terms is, I'm going to look at my squared terms. I'm going to use the number that's added all together. So that's going to be 40. So it's going to be s squared equals 40 minus the summation of all my terms squared. I'm going to keep those parentheses there because it's the summation of all my terms, which is 12, and then the squared needs to go on the outside of the parentheses. Once again, this is a difference here between whether it's the parentheses are included or not. Then that's divided by n, which once again, n just represents the number of terms we have, which is 5, and then everything is divided by 5 one more time. Now this looks like a little bit complicated of a formula, but luckily we can just type this whole thing into the calculator. If you do parentheses around the top, and then type 40 minus 12 squared divided by 5, and then close your parentheses, then divide by 5. As long as you put those parentheses around the top, this should be able to go in your calculator, and we're going to get our summation, or our s squared, or your standard deviation squared, is equal to 2.24. And then lastly, if we take a square root, our standard deviation, which we sometimes write S, or we sometimes write that sigma letter, which was like that circle with a hat that we used on Friday. Whichever letter is fine, is 1.49. And if we look, this is the exact same answer we got from our previous problem using the other method. So both these methods will get you the exact same solution. It's just two different ways of solving for it. This one uses that table and a little bit more of a calculator feel to it, while the other one is more of a, you got a step-by-step approach. But let's break down these steps like what we did with that last one. So breaking this down into 5 steps, I know this is kind of an intimidating formula, but breaking it down into 5 steps. Your steps are, number 1, create a table of values and their squares. So we're putting on the left side, we had the x's. On the right side, we had the terms squared, and we created that little table. So we put them all in, and then we added them up. So you add together each column. So we added up our left-hand column, then we added up our squared column. Next thing we have to do is plug in the results into the formula. So we took those two numbers and we plugged those into our formula with our squareds going first and then our terms that are squared going second. Then we type this whole thing into the calculator. Once again, it's helpful to have parentheses around the top. And then we took the square root of that answer, and that was our final step. So let's look at one other example of this, and that's where we'll call it for a day. All right, so I have some bigger numbers this time, so it's a little bit more intimidating. I have 36, 42, 37, 41, 31, 45, 39. So once again, we're going to go through these steps. So step number 1, I wanted to create my table. So I'm going to create my table with my terms and then my terms squared. So I'm going to put 36, 42, 37, 41, 31, 45, 39. So now when I square these terms, I'm going to get some pretty big numbers. So it's okay if we end up with some larger results in this. So if I look at these numbers squared, I have 12.96, 1764, 1369, 1681, 961, 2025, and then 1521. All right, so those were all our terms. Now, once again, once we created our column of our normal terms and then the square terms, our next step was to summate them all together, sum them all together. So that means I'm going to look at my left-hand column, and I'm going to add all of these numbers together. So if I do 36 plus 42 plus 37 and so on, I get 271. And if I look at my right-hand column and I add all these terms together, all my right-hand column together, I can get 10,617. All right, so those are my two values that I'm going to be using that are going to plug into my formula. So now our third step, once again, once we got those sums of our columns, we had to just write it into our formula. So our formula was my variance is equal to the summation of all my square terms, which is the 10,000, my right-hand side column, my 10,617, minus the summation of all my terms squared, which is my left-hand column, the 271, divided by the number of terms. So I have 1, 2, 3, 4, 5, 6, 7 terms. So I'm going to divide by 7. And then all of this is divided by 7. Now, once again, I like to put parentheses around the top when putting this into the calculator. That way it makes sure to not only, it's not going to be like divided by 7, divided by 7. Because if you don't put those parentheses in there, it's a possibility you might the calculator might not read it right. But I forgot to put my parentheses and squared as well. Sorry about that. So once again, we're going to type this whole thing into the calculator. So I'm going to type parentheses 10,617 minus parentheses 271, close parentheses, squared, divided by 7, close my other parentheses, divide by 7 again. And we're going to get s squared to equal 17.92. And then lastly, take the square root, and we get s equaling 4.23. So what this is saying is the average distance from each of these points to their mean is around 4.25 is the average distance from each of those points to the mean. And this can be handy for helping us show that, okay, if I get a point that's farther than 4.23 away from my mean, then I can assume my data, or I can assume that point is on the ends of my data, on the farther out part of my data. But if it's less than 4.23, I can assume it's closer towards my mean. It's pretty close to the middle. And so that's what that standard deviation is helpful with, helping us. From here, we're going to look at, we're going to work on an activity where we're going to compare two brands of paint and try to figure out which brand of paint we think is better or more reliable. So that's what you're going to work on next. So we'll end the video there. Let me know if you have any questions. And yeah, have a great rest of your day.